Hello and welcome to session 281 in the AISafety.com reading group. Tonight we will be discussing the article Scale, Schlep and Systems by Ayaya Kotra. Ayaya Kotra is the Senior Program Officer for AI at Open Philanthropy, and Kelsey Piper, who co-wrote the article, is a senior writer at Vox. This is posted on Kotra's blog Planned Obsolescence about 2 weeks ago. So Ayaya Kotra starts with an observation that if you go back in time something like 20 months to January 2022, large language models was not really something that a lot of people cared about. And in February 2023, suddenly there's 100 million people using ChatGPT. And argues that this shows that there's been an enormous rapid progress in large language models. So I feel like I'm kind of nitpicking here, but I do actually have a point. So obviously there's a sense that just perception is very different from progress. These are two very different things. I'm also kind of disagreeing with this idea that you can argue for a point by selecting two really arbitrary points and just looking at the slope in between these two. Like why January 2022? You could have said October 2022, where large language models really were not that much more interesting, and that in that case you could that was the period where I think it really took off. But this is kind of nitpicking because even though I don't agree with the argument, I do believe in fact that we have seen really rapid progress in large language models. This is something that has surprised a lot of people, including experts, and Ayaya Kotra asks people to register their forecasts. My forecasts are that in general most trends will continue roughly. I think one of the trends that may break is OpenAI. I expect they will regress to the mean in that they have overperformed my expectations substantially. Another prediction I have is that the major labs that are building the next generations of frontier models are in sync, in the sense that all of them will release the next version, the next generation at the same time. So I expect that there will be very little public progress until GPT-5, and then Anthropic and DeepMind and OpenAI will at the same time release the new generation of models, and that will indeed be quite explosive. I expect there is a possibility of a literal intelligence explosion, but I mostly expect we'll get a general level of intelligence in these models that are just below top human experts in particular fields. Another I don't know how brave this prediction is, but I expect that robotics will be the next major fields where we will see multimodality rather than video, and I expect we'll see transformer-based architectures basically make the entire field of robotics superfluous within half to an entire year. So that's I think it's still a somewhat brave prediction, maybe. Okay, so why are we seeing this progress? Kotra suggests two things: scale and Schlep. Let's start with scale, because that's probably the easiest one to get a handle on. This is a TPU, and you have built just larger models with more parameters, and you use more compute to train it, and you get larger data sets. This is the kind of thing that everybody knows, that this is the big thing that is driving large language model progress. Of these three, I think I would put a question mark on the larger data sets, because there has been GPT-4 has been trained on a substantially larger data set, but it's a lot less clear to me that this is really what is driving the performance. Some people believe that it's primarily larger data sets, and some people believe that it's a much smaller part. And I'm in the camp that believes that the larger data sets is actually not the thing that's driving this. Another thing that's obviously driving this is Moore's law. Moore's law is generally like the original formulations is about how many transistors you can fit on a die, and the practical implication is how many floating point operations do you get per dollar, and that seems to be improving at a rapid exponential pace. Another thing is tweaks to model architectures, optimization algorithms, and training processes. This is something that AI Quadra puts into the word scale. So if you come up with a smarter algorithm, that's also kind of scale. And this is something that I want to object to. And I think this is a major weak point of the analysis, because the algorithmic progress is really, really important. And it is very different from the other things, like the things that people normally call scale. By calling algorithmic progress scale, we end up with statements such as this quote: "Scale is by far the biggest factor in improvement." And when people hear this, they think, "Oh, it's all just throwing more dollars at the problem." And I think that is that's not what AI Quadra means, but I think it's a very misleading interpretation that's very easy to get out of this this way of cutting reality. If we, for instance, took the current budget that OpenAI have and put it back in 2018, then I predicted that we would get dramatically worse results. Like, I wouldn't say all of it has been it's an interesting idea, like how much worse would it perform without the algorithmic insights. I think that would be driving at least half of the improvement, but that's my intuition. I don't actually know, and it's of course impossible to travel back in time. So if I want to dig a bit deeper into why I think this formulation is problematic, I need to bring up this good graph that I've in fact shown many times in this reading group. This is from Nick Bostrom's 2014 book Superintelligence, from the chapter The Kinetics of an Intelligence Explosion, with the idea that, well, this is probably 2014, and there's some time until a takeoff, and then at some point models like the best models in the world, that maybe GPT-4 starts being able to meaningfully contribute to its own development, and then it increases until most of at the crossover point, precisely 50% of the intellectual, like IQ hours, if you can say something like that, is from itself, and then it continues to be like more than the rest of civilization, and then further off. And so this is the takeoff. Okay, I think this is a really important graph, and getting a strong understanding of these dynamics is really important. So if we try to locate ourselves on the graph, I think it's pretty clearly that we are somewhere in this area. Like if I learned, for instance, let's say I learned that OpenAI don't use GPT-4 internally, that would be really an enormous update for me, in the sense that I would strongly expect OpenAI to in fact be using GPT-4 internally in some way. I would probably believe that we are not yet at the crossover point. I believe that most of the brain power that goes into making the next generation of language models are not from GPT-4. So when we think about what goes into making GPT-5, the way I conceptualize this is that there is like intelligence, and then there's other things like chips and compute and data and training feedback and all these kind of things. And the word that have previously been using for this is scale. There's intelligence and there's scale. When Adjaya calls everything scale here, then it obscures the intelligence input, the recursive self-improvement that is absolutely crucial. And of course, in a takeoff, the recursive self-improvement is like the obvious crucial factor. Going back to the article, Kotra asserts that scaling will continue. We've seen scaling cause improved performance at all skills and tasks, and it can probably scale a lot. AI expects probably at least a couple of orders of magnitude more. I think AI is correct in this, but she doesn't really provide any kind of argument for this, and this is a very controversial point, and in general you should provide more evidence if you give like controversial opinions. So how much do I think this scaling will continue? Well, I said that I think trend lines will continue roughly. So if we look at the strategically relevant tasks, the six, for instance, that Bostrom has defined in his book Superintelligence, I think GPT-2 has had an IQ of something like 75. GPT-3, 95, GPT 3.5, 115, GPT 4 has an IQ of 135, and like you can try to scale from there and guess where GPT 4.5 or 5 or whatever the next is going to be. Like this is roughly my view of scaling. Like this is obviously like you can't actually say IQ of these language models, so this is like a very informal way.
Wait, is that like a literal belief of yours that
This is not a literal belief in the sense that like this is a way metaphorically at gesturing at something. Obviously when you actually try to do IQ tests, then they're timed, and that of course gives these models an extreme
no,
advantage.
I mean like
Um,
do you actually believe that GPT-4 can strategically behave in the way that a 135 IQ human can?
at certain tasks, I believe that it is in fact capable. Like depending on what kind of code you're writing, I have certainly seen some
Mm.
really brilliant code out of it. I've seen it be able to do a number of things that I feel very strongly that even most people couldn't do. Um, uh, like uh, like some of it is like you can of course there's been examples of like trying to come up with a way to take over the world. That would be like the most relevant strategic task, but there's also been a lot of like writing where I feel this is at a really high level. um, uh, so this is roughly my belief, yes.
Okay.
Like
I mean, it's just like
Eliezer or Cristiano.
I
it just seems to
Sure.
me that if this was anywhere near true, then you would be able to plug them directly into jobs much faster and more effectively than um, we're currently doing.
Yeah. So I think this is basically only a matter of Schlep. And I think if we get the Schlep right, then I believe GPT-4 would in fact be able to substitute, like assuming perfect Schlep, then I think GPT-4 would be able to directly replace a dramatic number of people who are working with text input and output. Yes.
Right, but as they are right now, what it's just it seems like a really big overestimate. I mean, I guess if you just say, "Oh, it's really good at code and creative writing," then that it could perform coding and creative writing to um, the IQ levels you listed. I would
Mm-hmm.
actually say it's an overestimate, but not by too much. But for other areas like agentic action or um, like behaving as a research assistant, it just doesn't come close.
Um,
I would say
mm,
that GPT-4 performed, well, GPT 3.5, which is what I've had the most experience with, underperforms like a IQ 90 human at like doing research. But then again, I don't have it that much experience with IQ 90 humans, so there's that.
Yeah, I think there's like a lot of people probably overestimate IQ 90 people, but like these numbers are of course very rough, and depending on the exact structure of the task, it can easily go at least 5 to 10 IQ points up and down. I would not at all be surprised. Like this is like these numbers are very rough, and I probably should have rounded them to the nearest 10 to make them seem more rough. These are rough numbers. But in general, I think for some of the interesting strategic tasks, I do in fact believe that GPT-4 is performing many orders, many standard deviations above the average.
And by strategic tasks, do you just mean programming or?
So by strategic tasks, I'm mostly thinking of Bostrom's 6 cognitive superpowers, which are intelligence amplification, strategizing, hacking, social manipulation, technological research, and economic productivity. But one of the big reasons, and in particular for the area that's economic productivity, there is one important thing missing, and that thing that is missing is Schlep. Now, some people Schlep is a Yiddish word. Here is Paul Graham, who claims that this is something that is in general use in the United States. I must admit, like I know enough Yiddish to understand most of Weird Al Yankovic's song "Pretty Fly for a Rabbi," but I had in fact not heard of the word Schlep. But apparently it means a tedious, unpleasant task. So these are things like prompting language models, figuring out how can we change the prompts to get better answers. How can we tailor the prompts for specific use cases? How can we address hallucinations by having another step where we ask the same language model, like, what are your sources? Why are you sure of this? And are you actually sure? Creating data sets and fine-tuning on them, creating tools and plugins for the models, and finally packaging all this into products. These are the things that A.I. Kotra calls tedious, unpleasant tasks. And I think both AI and I agree that this is like the big thing that is missing to unlock the economic potential of large language models. I kind of disagree with calling it Schlep, however, in the sense that these are really not unpleasant tasks. This is actually really, really fun. Like I would totally be doing this if not for the fact that I would expect this to be like the thing that destroys the world. Like people are doing it for free, and people are doing this kind of thing in an open source way. And the reason, like when people think about Schlep, they're thinking this is something that people will only do if they are paid for it. But actually, like figuring out how to use these prompts is really, really fun, and people are doing it a lot. And that's probably also why there is so much action in the open source scene. So the most concrete example of Schlep that Kotra has is chain of thought prompting. Like explain your reasoning in several steps. This is a method that has been proven to work for large language models. It works for humans, and we can say like theoretically why we expect this to work. There are other ways. A pause token seems to be a related technique that also work. There is the human feedback and reinforcement learning from human feedback that is also Schlep. We could easily imagine many other things in Schlep, such as like scratch pads and meta streams, full-featured text editors, things like that. So there is quite a lot of work to be done. Interesting, these techniques seem to work better for larger models. So it seems that there is a synergy between scale and Schlep. And that's kind of ironic because the first years of this reading group most people were arguing that this was a thing that would not happen, that we would see diminishing returns on tools and algorithms once we've plucked the low-hanging fruit. But that seems, in fact, not to be the case for the world that we're living in. In particular, one of the Schlep-y things that needs to be done is to change the large language models into systems. This is, in fact, really, really important and a task that is very easy to overlook. AI Contra compares InstructGPT with ChatGPT, and the difference is basically presentation, user experience, and marketing. It's the same underlying technology, but obviously ChatGPT had a dramatically larger impact than InstructGPT. There are other systems. Khan Academy has this one-on-one math tutor. That's also a difficult thing. You need to pull in many other tools. You need to integrate them. You need to test them. You need to validate them, etc. And that is a big thing that could potentially unlock an enormous amount of value. In particular, the most ambitious part is, can we use this to make the large language models into agents that take actions and act in the world independently? This is something that's been theorized. Here again, Nick Bostrom from 2014 gives an explanation of how to change what he called an Oracle AI into a Genie AI, in fact, this I don't know how much credit Bostrom should get for this, because it's in fact quite easy to take a large language model and just turn it into an agent. And also GPT is perhaps the simplest way. You just tell it a goal and then ask it to generate something that it can use for its own prompts and take some kind of specific actions, like write emails and what have you, towards that goal. So it's quite easy to turn it into a bad agent. It is substantially more difficult to turn it into a good agent. Lilian Wang has written that 3 of the common limitations that people run into when they are trying to turn large language model into agents are a too low context length, difficulties in planning and decomposition, and the reliability of interfaces. So these are kind of this match into AES framework quite well, in that the context length is basically a matter of scale. Planning and decomposition is basically a matter of intelligence, and reliability of interfaces is basically a matter of Schlep. So it seems like we have, in fact, these 3 things that are holding back agents. And of course, AutoGPT is just the very first thing. People with serious money and people with serious skills, serious companies are trying to do better. And AI Contra is optimistic in the sense that this could dramatically improve usefulness. And this is the overall conclusion, that scale and Schlep are things that mutually reinforce each other. So I fundamentally agree with this, and the question for me is, will this scale to a superhuman level? Will we get a super intelligence? I think the word AGI has now been redefined to mean super intelligence. I think Schlep is not enough to reach what people will call AGI. There are, to me, some fundamental limitations in language models that mean that we are, even with a lot of Schlep, unlikely, even with perfect Schlep, unlikely to get something that's above the human level. But I also think that there's a good chance that almost all the Schlep that we'll be doing will be on things that aren't really very relevant to AI safety.
Well, I'm sorry. How can you believe that, and at the same time believe that GPT-4 has the strategic capabilities of someone with IQ 135?
I think these two are, in fact, that's the obvious answer to that would be that someone with IQ 135 is in fact not a super intelligence. So, on the face of it, there is no contradiction between saying that even if we do a lot of Schlep, we won't get a super intelligence out of someone with an IQ of 135.
But I mean, if you have a lot of, I mean, if you scale up IQ 135 people indefinitely, at some point you're going to get a super intelligence that outperforms our civilization by a lot.
Yeah, like depending on how you define the word scale. When I say scaling up, I mean scaling up to something that is more intelligent. So if you continue by like on generally the path we have to GPT 5, GPT 6, GPT 7, GPT 8, like at some point we will reach something that is smarter than any human, no matter how clever.
Um, okay. And I mean, I'm just wondering why you think Schlep can't take us to super intelligence. I mean, it's not obvious that you can't with more prompt. It seems like there's a lot more low-hanging fruit through Schlep on a system like GPT-4. I
Um,
mean, it's like if they're 135 now,
mhm.
how much? It's just that in my mental model, you can get to um, better than any human ever existed through Schlep with GPT-4. And what do you think are the limits for that?
So like this is overall what can't GPT-4 do is a really interesting question. And like if we go back like 1 or 2 years ago, a lot of people were talking about this, like what are pointing out there's this thing that GPT-3 can't do and this thing that GPT-3 can't do, and now of course GPT-4 can do a great deal of these things. And the people who are pointing out things that GPT-4 can't do are not necessarily proven wrong, but there's a lot fewer of them. I think there are, in fact, substantial things that GPT-4 can't do. Like, just here, planning and decomposition would be an example where I feel ChatGPT is substantially lacking. So, and I think like a lot of Schlep probably will not fix that. Like the only way to like not the only way, but I think the best way to make GPT-4 have better planning and decomposition abilities are by scaling it up. And of course, I that's what I expect will happen, and that's like I expect we'll work hard on Schlep, and I expect we will um, solve this problem. Okay, so yeah, that's all for today. Thank you, and see you in 2 weeks.